Yes, sir.
Yes, sir.
All right. So we are going to discuss the basics of soil mechanics this afternoon prior to the uh, topics for shear strength of your soil. So before we move on to the shear strength of your soil, we have to learn the basics of soil mechanics first. I think I need to wear my headset para sure kung dili maputol later.
How about that? Can you hear? Can you still hear me?
Yes, sir.
Right.
Yes, sir.
So previously we have discussed uh, rock strength and rock mechanics, and how rock appears to or reacts with shear stress applied or confining stress applied to it, and how it shears when the elasticity limit of such rock or the intact rock will be attained. Now we are going to discuss the soil properties and the mechanics of soil. So please be guided with this lecture outline. First, we are going to discuss the origin of the soils, the three-phase diagrams, and some of the important terms and the relationship of the phases of the soil, and of course, finally, the liquidity and plasticity limit of your soil, which is shortened as called Atterberg limits. So, generally, in geotechnical projects, you have to evaluate not just the subsurface bedrock or the properties in terms of engineering properties of your surface bedrock, but we are going to examine yet to the properties of the soil, right? So you cannot expect that in every project site you will be encountering uh, just bedrock. Of course, there could be a thick burden or a thick overburden soil sa imuhang project site. Now, so R2D sa rock mechanics, we discussed the integrity of the rock in terms of the density of the fracture, right? Because it determines the general strength of your rock and the influence of such to the possible occurrence of slope failure. Now we're going to discuss the soil. So basically, your soil are just products of weathering of your rocks, be it mechanical disintegration, be it chemical decomposition. So these sediments were not totally lithified. I mean to say, during transportation or after the erosion of your sediments and during transportation and deposition of your sediments, it did not undergo uh, diagenetic processes, but rather it mixed with some organic materials, which will lead eventually to the formation of your soil. Note that soil is just a combination of disintegrated rock materials and organic materials plus air, or yeah. So this can be, or these materials or weathered rock materials were eroded and transported by transporting medium, the same transporting medium, be it water, wind, or in some places, glaciers. Okay. So this soil, however, can be triggered, or soil formation can also be influenced by constant uplift of the locality or specific regional location, the activity of volcanism. Yun. Because at some point, if there's an active volcanism, your uh, pre-existing soil will eventually be part of those buried materials with or materials buried in ash or buried in volcaniclastic. So magkakaroon ka ng paleosols in this scenario, because the next soil or the next layer of soil that will exist or occur in the area will be coming from that newly deposited sediments or volcanic elastic sediments, especially kung nakasaymohang volcanically active na regions. So meron tayong anim na klase ng soils. We have glacial soil. This is common to your polar region or mga colder regions in the North and South Pole area. The alluvial soils. So these are soils that are transported by river streams, uh, and it's also deposited along banks. Your lacustrine soils are common to your lake sediments or deposited in the bottom of your lake basin. This is actually combination of organic materials and silt mud materials. Your marine soils uh, is formed by deposition in the sea. So you have a natural organic materials from marine environment, and then you have an alluvial sediments or pelagic sediments that will be deposited in the seas. Your Aeolian soils are represented by less deposits in arid regions. So these type of soils are consist mainly of silt-sized sediments. And lastly, you have your colluvial soils. There's are the kind of soils that are products of uh, previously collapsed materials. So ito yung mga landscapes na naging lupa. So actually in mountainous regions, medyo ito yung dako nga problema because there are subdivisions that are actually constructing houses or constructing uh, subdivisions along the colluvium. That's why uh, it's a sardus if the developers were not aware or did not conduct geological assessment or engineering geological assessment first before uh, drilling. So we do have three phases of your soil. You have the solids, which is basically consist of soil particles. You have the liquid denoted as W, which is consists of water and electrolytes, and your air, of course. So in this schematic diagram, you have your solids represented as S, and then along the interstices of your solid particles, you have water particles, and there are some air bubbles which traps your air in this bulk soil sample. So graphically or schematically, it has been shown as this. So it has three phases. You have solid or your uh, soil particle, and then water, and then air. In this case, you assume that the mass of your air is almost zero. Almost zero, not necessarily zero, guys, but its amount is, or its mass will not be that of significance, or the values will not be that of significance. So in this case, the combination of your mass of your water and the mass of your solids will be considered as the total mass of the whole sample. However, the volume will be the other story of this scenario, because the volume must equate the total volume of your soil sample, the total volume of water in the solid, and the total volume of the air uh, trapped within that soil sample. So how are you going to determine the volume of your air? So first is you have to know, or you have to determine the volume of water and volume of water with respect to the volume of your soil. If you have determined that, the remaining volume will be definitely the volume of the air. Take note that in soil science, you have to conduct tests prior. You have to conduct measurements prior to any laboratory testing to your soil sample. So you have to determine the mass itself during the extraction of your soil sample from the field, and prior to oven drying, and submerging again to water for saturation test. Now, the volume of your voids can be denoted or can be determined by just adding the total volume of your water and the approximate volume of your air that are present in the sample. So the three-phase diagram of soil, you have air, which is shown as white spaces or voids within the interstices of your soil particles, which is represented as brown uh, particulates here. Your water, it's along the pore spaces as well, and serves as a bond for the particles, and your solid represented in brown. However, we do also have two-phase saturated soil phase. So ito yung tinatawag na saturation of water. So basically, you do not have air components, or you do not have uh, air voids or air pockets in your soil sample because it is saturated with water. So that's why two-phase siya. Another type of two-phase is the dry soil. Kung kanina we have the saturated soil, ito naman dry soil. Dry soil. In this case, water has been eliminated from the system, leaving air pockets along the interstices of your soil sample. So let's check the phase diagram in schematic form, which represents or representing the solids and parts of water and liquid, and parts of air and other gases that present in your soil sample. This is just similar to the previous one, only that the symbols or saan eh? Only that you have to take note the following symbols for that. This will be important notes for later. So let's check for the volumetric ratios for your three-phase diagram or three-phase uh, soil example. So for void ratio, which is denoted as E, all you have to do is you determine the volume of voids times volume over volume of solids. So in this case, you have to determine first the volume of voids. How are you going to determine the volume of voids? These are just the combination of the volume of your water and your volume of your air. Sorry, water air. So that's volume of voids times I over or divided by the volume of solid. So that's how you get the ratio. So in this case, you just have to consider the if you are going to determine the total volume of by parts, mean to say pila sa usa ka bulk sample ng lupa mo, pila ang solid dito, pila ang uh, voids, mean to say mga materials or mga spaces that can be filled by water or air. Porosity, on the other hand, has different is a different value which is denoted in n percentage. So in this case, by the way guys, the void ratio lang guys, wala lang siyang unit because they have the same these two has the same units, that's why na-cancel out lang na siya. Similar with your porosity, which is in percentage. Now in this case, sa imuhang percentage of your porosity, the volume of voids will be divided by the total volume of the whole sample itself. So mean to say, not just the volume of solid, but the volume of voids will be divided to the whole bulk sample, not just the solid. So hindi wala taga determine ng ratio, but rather we are determining the total porosity of your bulk sample. So what is the difference between the ratio and your porosity? Your porosity is or your porosity exemplifies the whole volume of your sample. Okay, with respect to the whole volume of your voids with respect to the whole volume of your sample, while your void ratio denotes the volume of your voids with respect to the volume of solids alone. Okay, ratio lang, mean to say kung magkuanta ato ni siyang i-analogy, kung gusto mo example let's just say sa imuhang kuan, uh, imuhang sandstone, yan. So sa imong sandstone, pila ang solid, nakay of course you are aware that it has uh, void spaces. So in this case, all you have to do is i-determine ra nimo sa fraction of 1, sorry, sa if the voids ratio is 1, so kana nga 1 pila ang parts for uh, voids, pila ang parts for solid. So mean to say sa total bulk composition or sa bulk property sa imuhang soil sample, pila ang ratio for the voids and pila ang volume ratio for the solids. While the porosity, you are going to determine the volume of voids with respect to the whole volume of your samples. Mean to say, anang volume sa imong voids, i-divide ra nimo na siya sa tibuok volume sa imong sample. Mean to say, kasali din ang iyahang own volume. Only that, na ani addition with the volume of your solids. How about saturation? So, ang degree of saturation will vary from 0, meaning to say dry, to 100%, meaning to say saturated, meaning to say the void spaces are filled with water. Water, guys, because this is not a kind of two-phase diagram or two-phase na example wherein dry ang imong sample. So how about the saturation? All you have to do is to determine the volume of your volume of your voids that contains water and the total volume of your void. So how are you going to determine that? So maraming approach ang ginagamit this one based on the ASTM standards. One of which is that sa laboratory, ilulublob nimo ang sample sa before nimo ilublob ang sample sa water, first is kukunan mo muna siya ng uh, void ratio and then the porosity percentage para makuha nato ang volume ng water na nandun at saka volume ng total para makuha nato ang saturation, kailangan nato i-determine ang water na nasa loob ng sample mo. So what you're going to do is isa-submerge mo yung water and then i-ratio mo lang siya with the total volume of your voids as determined by the previous examination or test. But how about the weight ratios? So kanina, volume ratios tayo. Ngayon, we are going to consider the weight of the samples. So first is that to determine the water content. So ito yung sinasabi ko kanina sa uh, determination of your water that is contained in your pores or your voids. So how are you going to do that? By means of this formula. So you need to determine the weight of your water and the weight of your solid itself. So that's why timbangon pa nimo. Aside sa magkuha ka sa volume sa imuhang particles or solid particles and your water, you have to weight your sample as well during the extraction, hanang na-extract ninyo siya sa yuta, and after the laboratory test para naakay point of comparison and difference. But how about the soil unit waste? So ito, kung kanina, weight ratio by means of water content, now we are going to determine the soil unit. Mean to say, the main soil properties or the solid properties itself. So in this case, if you are going to determine the dry unit weight, denoted as gamma D, you have to determine the weight of the solids, soil solids. In this case, tatanggalin mo ang water. So, posibleng nagkakaroon ka na ng drying in this case. So, imo na siyang i-oven para ma-determine mo ang weight sa imong solid. Divided by total volume of your soil. So, what does this mean? Unsay gipasabot ani total volume of your soil. So, mean to say, before pa lang ka nag-dry weight, conduct ani na anakay data from the previous ratios. Mean to say na nagkuha na ka sa imong volume ratios and mura na siya imong i-run diri sa formula for dry unit weight. But how about for the total wet, bulk, and moist unit weight? So in this case, it has been denoted by lambda ay gamma lang. So mean to say total lang na siya if it is not subscripted with uh ano ni any values or any variable. So in this case, the total weight of your soil must be divided with the total volume of your soil. So pag sinabi mong total weight, that includes the weight of your solids and the weight of your liquid. With assumptions, because this is in bulk and moist weight, with assumptions that the weight of your air is approximately zero. Mean to say, kung naman siya weight, it would be quite insignificant or less of significance to be considered in the computation. All right. But if you have noticed that the water in the voids or the pore spaces of your soil is not that significant or it's not that high, meaning to say there are some voids or portions of the uh, openings or pore spaces that are filled with air. So you have to determine the volume of that pore spaces to determine the weight of your air itself. But how about the saturated unit weight? Let's consider that your saturation is 100% and the volume of your air is zero in this case. So I mean to say, almost, no, not almost, wala kay air pockets, wala kay air sa imuhang soil. So in this case, your soil is generally saturated with water. So the formula for that is you need to determine the weight of your solid soils. Mean to say the weight of your soil na wala siya tubig, mean to say dry, plus the weight of your water. Kadtong na wala pa siya or kadtong basa pa siya. Okay? So that's why imo good na siyang i-determine kaning WW i-determine sa guna nimo. That's why it's very important to determine the weight of the sample prior sa any laboratory activity or any not just weight, the volume of the sample, the weight of the sample and the mass of the sample with respect sa ay kanang with respect sa imuhang any laboratory as activities. That's why naasa kay uh, evaluation ana because the laboratory analysis will determine the difference or the variances. So note that the density or the unit weight or ratio sa which connects the volumetric side of the phase diagram with the mass or weight side. Okay? So ang weight man good guys with respect sa imuhang pool of acceleration due to gravity. Their mass itself is kanang mass lang jud sa imong sample without considering the uh, gravitational pull. How about specific gravity? So, in this case, gigamit na nato ang uh, unit weight of your material with respect sa unit weight of your water at 4 degrees Celsius. So, how are you going to determine the specific gravity? All you need to do is the weight of your solids divided by the volume of your solids times the unit weight of the water with at 4 degrees Celsius. Munang Y or gamma W. So ano ang ano ang value nito sa inyong physics? Anong value nito? The unit
Density,
weight
sir. Oh,
the unit weight of your water at 4 degrees Celsius. Anong value nito?
Gamma? Hindi.
Ang say gamma.
Mali, mali.
Anong value nito?
1, sir.
Are you sure it's 1? Wala pa. Paano mo siya ni-determine? Dito. Isa-submerge mo siya sa water yung sample mo. So, paano mo siya ma-determine yung general submerged unit ng water mo? Kaya nga wala sana ako gi-appeal ni guys para makbitik na mo dire. Anyway, sige. Tingnan muna natin to. You already determined the saturated weight of your the saturated weight of your soil. Okay? Nakuha na nimong saturated weight. Unsa kay saturated weight? Unsa pasabutan na? As a recap, unsa nang saturated weight? Unsa pasabot niya? You are just considering the.
Water og soil, sir.
Alright, very good. So water ug soil lang sa imuhang sample. Wala kang air in this case. But in this case, how are you going to determine the submerged unit of your or submerged unit weight of your uh unsa ni sample? This is kabaliktaran of your sorry, did not kabaliktaran, that this is the amplified tawag ba murag derivative yon. This is the derivative of your total weight, unit weight or moist weight sa imuhang sample. So in this case, you have to subtract the unit weight of your water itself or the total unit weight of the water itself. I-subtract nimo siya from this uh unsa ni from this value of your saturated weight itself. So, how are you going to determine this one? Paano mo madidetermine ang gamma W or the unit weight of your water? Sige. Kung kani atong gamiton, tanawan niyo siya, kanin siya relative ni siya dire. So unsa ka na siya? Tanawan ninyo. Unsa ka atong gamiton, guys? Hmm?
Answer. Ang answer sa equation 3 kay minus sa answer sa equation 2.
Answer sa equation 3, which is this one, minus the equation 2. So, but remember, this is just the wet or moist unit weight. Okay? The total wet or moist unit weight. So, do you think by subtracting this one with this one, sorry, tama ba? Subtracting this one with this one, no, but subtracting this equation or the value of this one with this one, so number 2, you will have a submerged unit weight. Or do you agree with, since ito to,
Sarita,
sino
sir.
yan? Sarita, do you agree with Sarita? You can get the submerged unit weight of your soil if you subtract the values of your saturated weight with total wet or bulk moist weight or bulk unit weight. Do you think? Huh? What do you think? Oy, nangahiman. Tingnan nyo. Sige, examine this one. Examine this one. Anong difference nila? Ha? Bakit sila pareha? Ha? So, examine this one and this one. Bakit sila pareha?
Puro gyapon lang water, sir, nga weight di ay.
Okay? Uh-huh. So,
So basin 1 guro, sir. Equation 3 ug equation 1 ang minus answer.
wag ka waya gusob-gusob, guys. So, tanto ninyo. Ha? So, remember, guys, or notice this, guys, actually, so wala na ko ni siya na bantayan kahapon. Pero sige lang. Actually, dapat wala to. Because we are just considering the total weight of your soil here and the total volume of your soil. Gets ninyo? Nakita ninyo? Wala ko ni-react ni Dayan.
Wait, nakabantay sa
Diba? So that means, katong gisulting salita kanina, that this value minus this value is you will have the submerged unit. So basically, whatever the values that you get must be this one, the unit weight of your water. So in this case, you can determine the unit. Okay? Katong one nga inyong gisulti kanina, that is the specific gravity of your water. Okay? Which is this one. Unsay unit sa specific gravity?
Wala, sir.
wala.
Bakit?
Ma-cancel man, sir.
ang ilang units since it's only
Bakit?
a ratio between the uh, between the water and the solid particles, sir.
Ratio of ratio of their what?
Density.
All right. Correct. So now, so please screenshot this sample because you will be needing this in your quizzes or exams niya. So these are the expected values for your specific gravities of your typical soil samples. For example, your sand do have 2.65 to 2.67 range of a specific gravity, while your silty sand have 2.67 to 2.70 specific gravity. Guys, question, bakit mas mataas ang values ng silty sand kaysa sa silty sand soil mo kaysa sa sandy soil mo? Bakit kaya? Taas ang iyang specific gravity.
I think, sir, because it is finer. Tapos, and the and its pore spaces, sir, is filled with water on the air. I think.
Filled with water. Pwede. Sige. So, since it's finer, not necessarily finer, guys, but you still have sand components. It's just that naa siya silt, parts of silt, konting silt. So in this case, katong pore spaces or katong void sa imuhang sand or sa interstices sa imong sand, ma-fill inan siya og silt materials. Kaya since ang silt ni mga particles gagmay man, so sila tong fill in sa mga void spaces. Aside from water nga i-absorb sa imong silt particles, mo fill in po siya sa mga interstices sa imong sand. That's why mudugang siya sa weight. So aside sa water itself, the particles itself will be, or the general bulk composition or the general bulk sample sa imuhang soil will be compacted. So the more nga makompact siya, the more nga mubugat siya. While your organic soils, katong mga consist of organic materials have less than specific gravity. But your soils with mica and iron, so katong mga soils nga gikan sa mga volcanic rocks, product of disintegration of your volcanic rocks and formation of soil from your volcanic rocks will have 2.75 to 3 na specific gravity. These are the nearest values or values range based on the mineralogic components or mineralogic association sa imuhang soil that came from volcanic rocks. So please take note of these 6 fundamental definitions in the relationship between various physical properties of your soil. So muna atong discuss a while ago. So let's check the relationship between the voids ratio and the porosity. So your voids ratio is equal to the total volume of your voids over the total volume of your solids. Katotong, balikan nato siya. Yan, ito. Ito yan ha. So, na to. Yan. So let's expand this formula. So retain the volume of voids, but the total volume of your solid is V minus VV. Mean to say, your V here, ano yung V here? Ano tong nag-consist ng volume ng solids mo? Ha? Yung volume ng solids mo can be determined by the total volume. Actually guys, total volume niyan ng total rock mo, total volume of your rock minus the volume of your void. So ang mabilin, total volume of your sample. Gets?
Yes, sir.
Tama. So in this case, kung imo na siyang i-simplify, algebra niya siya. Both the numerator and the denominator, you will divide it with the total volume. You will come up with this equation. N is represented by a number. A number that is basically representing the porosity because these are voids eh. This one. So this the volume of your voids divided by the total volume represents the porosity. Balikan natin si porosity, which is the total volume of your voids over volume of your rock, or sorry, volume of your soil, total volume of your soil. That's why magkakaroon ka ng following or simplified equation that na E is equal to N over 1 minus N. 1 here is the total sa imuang sample. So aside from this one, kung na kay exam tapos wala gihatag volume sa imuhang total volume sa imuhang sample and then the total volume sa imuhang voids but gitagaan lang porosity. So then you can use this equation to determine the voids ratio of your sample. Kasabot? So these are just simple na mga mathematical manipulations of your equations. However, naputay kabaliktaran na your porosity can be determined by determining your or dividing your total voids ratio over your volume, which is denoted as 1 plus the ratio of your voids. So, yan lang yung determination ng porosity in this case. And we just use the simplified equations in the phase diagram. So, or on this phase diagram. So, remember that your porosity is denoted as V over VT or the volume of your voids over volume of or total volume of your sample, and your VV can be represented by E, mean to say total volume of your voids are is can be represented or represents the total voids ratio itself. While the total volume one here unsay gipasabot sa one ani unsa in this case kung diri gipasabot ana niya is ang imuhang total volume or the ratio of your whole total volume unsa na nang gipasabot sa one ani unsay gi-represent sa one ani ang imong which
Soil,
one
sir.
solid correct very good imuhang soil mo na gipasabot sa imuhang so mo na siya di ara sa imuhang equation and your E is represented by the combination of your volume of your air pocket air and water in your void spaces. At the relationship of your void ratio, your saturation, the weight of your sample, specific gravity. Please take note of these formulas. So these are just simplification. We all know that the total weight of your sample can be divided with the or can be determined by the weight of your water over the weight of your solids. That is how you determine the weight ratio of that particular relationship. But in this case, simplifying, if you're going to simplify this, you will come up you will come up with this equation. Paano siya nag-come up with that equation? First is the volume of your the weight of your water can be determined by the volume of your water times the unit weight of your water as determined in this section. This one. Okay? So determination of your submerged with respect to your saturation of the sample and your uh unsa ni wet total wet or moist weight itself. That's why you will be able to come up with this equation. So you are going to divide the denominator and numerator with the RHS by VV. So in this case, you will come up with this one. Okay? So, pwede ka mo gamit this ani. Actually, pwede ka mo gamit ani, guys. Pero kung whatever is given, but you can also use this equation. So, if you are going to determine the total voids ratio, you just have to divide the total weight of your sample times the specific gravity of your sample over the saturation to determine the voids. Same goes with saturation. You have to divide the total weight of your sample with its specific times its specific gravity over the total uh, voids ratio. And this can be very useful as represented there to solve any problems that is constituted in the three-phase diagram relationship. And the relationship of your unit weight your voids ratio, saturation, and specific gravity can be denoted by this formula. So kani sila guys, na-derive ni siya atong mga previous equations sa natong gi-discuss here. So medyo tinatamad akong i-discuss tong equation because this is math. I mean, this is just a simple math of the previous equations that we have discussed earlier. Ano siyang di come up, ana. Yes, kinsa to?
Sir, so hindi ko
Hmm.
lang hindi ko lang guess kung nasaan galing ang ano, gamma W?
Di ba balik na ta diha? Sige, paano nga to Sarita? Paano nga si Sarita na nagsabi eh? Paano nga?
Agi-subtract, sir, ang answer sa question 3 of second.
So,
Kanang
basically your gamma W ano saan ni? Tayo, isubtract mo lang tong dalawang equation na to. Okay?
So,
Subtract mo lang sila.
so
This
subtract yung
one,
subtract yung gamma at gamma saturation.
mm.
Gets ko na sir, thank you.
Okay. Saan ako to, guys? Right. Kindly screenshot this one. Ito yung mga formulas, important formulas na pwede mong gamitin to determine the relationship of your saturation, void saturation, the saturation of your soil saturation of your sample, and the specific gravity. Okay? Familiarize yourself with these equations, guys. And as much as possible, familiarize yourself with this symbol. Okay, let's have a sample problem. So, if you have a moist unit weight, moist guys moist unit weight of your soil that is 19.2 kilonewton per meter cube or cubic meter, and given that the specific gravity is 2.69, mean to say this is just the specific moist sample, and its weight is 9.8%. Mean to say the water weight it's 9.8%. How are you going to determine the dry unit weight? Dry unit weight, unsa to'y formula? This one. Okay? Pwede ka din gagamit ng, ano siya guys, gisimplify ra ni because mo may given, W man. Kung pwede ka rin gagamit ng ganito, like this one, WS over total volume of your sample, but in this case, you are going to determine the volume or total volume of your sample, which is hahaba ang ano mo, ansa ni solution mo. Okay? So why not? You just have to determine the total volume of your sample, and you all know that the total volume is equal to what? 1 plus the volume of, diba? So voids that is saturated with water. One represented, or one represents the solids here, and the W here represents the water in your void spaces, 'di ba? Nagets ninyo ning 1 plus W. Anong nahimo siyang 1 plus W? Nakuha niyo ba to, guys? Bakit siya naging 1 plus W?
yes, sir.
Okay, that's good. How about void ratio? So, ang iyang gigamit ani guys is this one. Either this one, pwede din itong void ratio niya. So, W GS over S. So, I think gi-manipulate lang niya ni siya. Yeah, nagdi-manipulate gud siya. 1 plus E. Ang 1 plus E, ano nga yung 1 plus E here? It's this one. Kani ang gigamit na equation. The volume of your solid plus volume of your voids. Okay, and dire ang 1 plus E is this one, total volume itself. Mhm. How about the porosity? The equation, katong simplified equation kanina. Okay? And the saturation, katong ikaduhang equation. So in this case, gigamit niya ang katong iyang transpose. Transpose ba tawag? Yeah, transpose to determine the saturation. So you work out on the available formulas. Okay, sa exam niya, sa mga exams na to, I will not stop you from looking at your notes to uh, check the formula, but as much as possible, you familiarize yourself ha. Hindi ko naman kayo pipigilan na mulantaw sa inyong notes or sa ato ang slides kung sa tong mga formula. It's just that at as much as possible, familiarize yourself with the formula. Dili pwede nga similar lang sa math guys nga unsa ni kung palantaw na mo notes magsalig ra mo sa inyong notes bibalag wala mo kasabot sa formula. Okay? So you have to practice lang kani siya dili na siya walay teacher nga maka pasabot dayon ninyo ani sa usa ka discussion. Okay? It's just that at least gitagaan ta mong idea unsay nahitabo and this one tingala mo nga present kanina nga mga formula na unang usob. It's because nagkakaroon ng simplification process. Okay? Gisimplify ang mga equation in these amples. To note, pasensya kay guys, these slides dili ni siya ako actually share this with you. So I was hoping or I'm hoping na nakatake mo screenshots lang for study purposes. Okay? Ayaw lang i-publish kay wala koy authority or wala ko taga iog rights to publish this one. And then example 2, you have the field density testing of your bulk density of a compacted road base, which is to be 2.06 grams per cubic centimeters with a water content of 11.6%. So W in this case. So specific gravity of your soil grain is 2.69. You have to calculate the dry density per saturation. Okay? So dagan kay ka makuha ra nimo ang imuhang unsa ni saturation with respect sa voids, the dry density, the ratio of your voids, the void ratio, and then the dry weight sa imuhang sample. So for this case, naakay 1, 2, 3, 1, 2, 3, 4. 4 kabuo answers. So, mugamit lang ka ato nga mga formula. Laruin nyo lang yung mga formula. Whatever is given to you. So, it is important na pag mag-solve mo yung nga mga problems like this one, you have to note first what is given. So, kung unsang gihatag, porosity ba, volume ba, 'di ba? Kasi kung unsang ihatag mo na yung inyong gamiton formula, dito magdepende ang inyong formula nga gamiton to solve the equation or to solve the problem. So the relative density, this is the volume of your sample as it has been reduced or as there is reduction that has been achieved because of compaction. Okay? So, kanang nakay original sample, pero gi-compact ang imong sample. So, na-compact siya, maybe tungod sa lithostatic pressure. So, the solids and your voids, pila ang change in terms of the change of your height or mean to say the change of the length sa imong sample or the voids of your sample and di ba? And what is the maximum state or the densest state for this sample to adjust to the relative or adjust to the maximum volume reduction. So, example, pag sinabi mong ito na yung V minimum niya as denoted as HVM, mean to say mo na ang iyahang density index. So ito yung mga ito yung tinatawag niyang in situ densiness. Mean to say, yan yung in situ density index niya. Pag sinabi mong ganun, mo to yung maximum niya nga ma-compact, mo to yung pinaka-maximum niya for voids to adjust or to for your voids to change in terms of height and volume, height or length, and as well as volume. So your density index can be expressed in terms of void ratios or dry densities. So mura na iyahan ko an. So ang imong DR or the density index or relative density index is equal to the maximum voids ratio. Mean to say this is the denoted as the loosest state, okay, of your sample. This one, the Emax minus the in situ void ratio of your soil itself. So katong atong gitest kanina, that katong E kanina mo ni siya ang in situ void ratio. In situ mean to say kadto pa tong wala pa nimo gi undergo any laboratory analysis. While your E minimum, this is the void ratio of your soil in the densest state. So this one, sorry. The void ratio sa imuang sample kapag na compact na siya maayo or na reduce na kaayo siya tungod sa applied pressure. So what could be the E minimum? So nganong minimum siya? Nganong gitatawag siya minimum void ratio? Then kaning usam ganong gi maximum ning loosest state, nganong minimum ning densest state? Yeah. Kinsa to?
Ako, sir.
Tapos ka na. Nag ano ka ba sa'yo? Nag-recite ka ba today?
Wala na, pumagod ako question kayo na.
Okay, sige.
Ah,
So,
so,
go.
so kung ano, kung mas compact, mas dense, meaning kunti lang yung mga pores ng hangin. Pero kapag ano, loose ang state, malaki yung mga pores, kaya kapag loose ang state, maximum ang pores. Kung dense ang state, minimum ang pores.
All right. Sige. Let's refrain from using pores na lang tayo kasi mahuna-hunaan man gud nato pore spaces sa sedimentary rocks. Kaya lang voids na lang for
Voice.
soil
Sige,
ha.
sir.
Let's
Sige,
use
sir.
voids for soil. Gigamit lang ako tong pores kanina para ma-imagine ninyo, but right now as much as possible if we are talking about soil, gamitin niyo yung voids. It's okay kung ang kausap niyo ay geologist din kasi makasabot ra na siya, pero kung civil engineer ang imong kasturya, matralala na sila because they are not really familiar with the term. Ito pala, yung term nila with DVV, kabante mo kanina natay VV, di ba? The total volume of your voids. Ang ilahang perception na is volatiles, the volume of your volatiles. So ang ato ang volatiles lahi din ang perception nato because atong volatiles ga kuha na siya og mga sa ni steam phase sa imuhang water. So lahi-lahi jud ta. Anyway, if ipa-complex pa jud natong maayo because kung mo'y given, okay? What if ang given is the dry weight, 'di ba? Wala kay given sa imong equation or wala kay given sa imong sample nga voids ratio pero na kay dry weight, then you use the dry weight itself. The minimum dry weight of your sample and the maximum dry weight of your sample can be used in this particular topic or in this particular scenario. So, paano mo ano sir nga wala ka nakahatag, wala sila nihatag og Emax or E minimum. Simple lang, kung imong sample na nakuha na siya na oven na ba, then wala ka nakuha, wala nimo nakuha ang data sa original or in situ void ratio niya, then you can use this one. The dry weight itself, the minimum dry weight and the maximum dry weight. Only that there's just mga simple na mga adjustments or mga simplifications sa imong equations. So always remember the density of the unit weight of your dry sample sa ani nga case. Your density index can be derived by dividing your sorry, uh, taking your dry weight, unit dry weight minus your unit dry weight minimum. Mean to say, kani siya na-apply na nimo ang pressure and this one over the unit dry weight maximum minus unit dry weight minimum. So it's almost the same with that sa imuhang or almost similar lang sa imuhang original formulas for the uh, density index sa imuhang sample. So your DR may vary from minimum to 0 for loose soil and to maximum of 100% for dense soil. Okay? So kung mean to say, kung 100% ang imong DR, mean to say, totally compacted na imong sample. Mean to say the relative density of your or the density index of your sample is almost uh, compact. Mean to say 100% dense. So and because of irregular size and shape of your granular particles, it's kinda not possible to obtain zero volume of voids, right? So if you remember the I know nagsedimentology man mo karon, di ba? Kay numdum mo atong mga regular shapes sa imuhang particles sa usa ka cubic volume na space. So magbutang ka og parehag sizes na mga particles, what will happen? Parehas like sizes. Imong ibutang atong ano.
Bigger void, sir.
Yeah. So na siya yung mga voids or na siya yung mga openings, right? Because they have the same area, they have the same size, ganyan. So, but in this case, imong yuta irregular ng size ana. Mean to say, lain-lain man gud siya, klase-klase na siya, sagol-sagol na siya. So, varying particle sizes, varying particle shape, then lisod kayo nga ma-zero ang imong voids, di ba? So in this case, pwedeng na mo fill in sa imuhang void spaces kay lain-lain sila siya irregular, but in this case possibly good nga ma-zero good kasi what if lain-lain jud siya og sizes and then once nga imong siyang i-place sa usa ka space, i-fill in niya tanan na void spaces katong mga gagmayng particle, i-fill in niya ang imong void spaces. So I don't know, kanina siya segue lang ni siya. If you happen to see this short clip ra niya siya guys sa tong professor gani nga kakuan siya. Gipakita niya sa iyang students ang usa ka analogy sa life sa usa ka tawo by using jar. Nakita na ba ninyo na gamit siya jar, butangan niya ping pong balls. Di puno niya ping pong balls. Nangutan niya siya, is it full? Ngayon students, yes. So, iyang unsa yang gibutang?
Tubig, sir.
Mga dili balas.
Balas di, sir.
Balas pa. Ay, sand. Oh, tama yun. Balas pala. Ay, balas na yung sand. Balas. Then, pagka is it full? Yes. Then, iyang gibutangan og water. So, mean to say, dagan pa kayong spaces na pwedeng ma-occupy within that voice. But, in this case, kung regular ang imong shape o ang imong size, pwedeng ka mga spaces ma-fill inan ato. That's why possible kang it is not possible to obtain a zero volume of your voids. So not possible. Okay? Or impossible. Okay, how about this one? You have your granular soils qualitatively. So you describe according to your relative densities. Sa imong granular soil, if you have a relative density of 0.15, kadto niya siya guys kani. I mean to say the relative index. So or relative density. If your relative density is 0 to 15%, then you are looking at a very loose soil deposit. But if it has 85 to 100%, mean to say 100%, let's say totally compacted sample, then you have a very dense soil sample. Sige, mga ito tayo example. Sa Negros, there is sa ato sa may somewhere in Dumaguete, if you happen to examine the soil, kato na lang inyong gi-visit sa Sibulan, katong quarry area. Tanaw ninyo, ang soil cover ato, unsa ka siya nga classification. kung i-compute ninyo ang relative density ato unsa ka to siya nga compute asa ka to siya na belong
So, nalo po si Bulan.
ha baka loose ba yon ay wala actually wala pa ko kadto sa quarry area sa Sibulan guys loose ba yon or dense is it dense
Medyo loose, sir.
loose ba siya very loose
I would say very loose.
okay so
Okay,
actually it's
salamat.
in loose so kalagmitan guys unsa nang naa sa dense unsa nang mga dense sample katong mga clay right that's why mga pag clay gani ang imong sample dense jud na siya it's because naa siya liquidity index so wala ay tagagamit sa DR for clay but we are using liquidity index so diri na mosulod ang Atterberg limits test so ang liquid limit test mo na siya determination of your uh, unsa ni pila ang kaya niyang i-absorb na water right so the soil is said to be at its liquid limit when exactly 25 drops are required to close the groove of for the distance of 12.7 millimeters, half an inch. So what will happen is that mag-create ka og groove sa imuhang soil. Groove unsa na siya murag kuan gani karuton gani nimo ang soil. Tapos continuous na nimo siyang buhaton and then imong i-determine ang of course gagamit ka ng tubig dito guys ha. So until such time nga mo expand man ang imong clay samples, di ba? Or clay soil. Pag mo expand siya, katong imong groove nga gigama mo sirato siya. So pag pag mo if you need 25 drops of water para mo close tong 12.7 millimeters groove na imong gigama which is half an inch in length, then that is the liquid limit of your sample. Galing nga nang nakadiscover nito eh. So ito yung apparatus niya. So gagawa ka ng groove, this one, yan. Okay? So sa groove na yan, magpapatakan in this case since clay imong samples mo expand na siya. Eventually it will close your groove. So the maximum na iyang the drops or nga imong kinahanglan para mo expand ang imong clay sample para mo close siya mo na iyang liquid limit. Now, the plastic limit of your sample is being rolled into threads. So, mura siya og mura siya lundrison until it becomes thinner and eventually breaks at 3 millimeters. Okay? So, imo siyang mura siya lundrison until maputol. Diba? And it will breaks at 3 millimeters. So, mean to say 3 millimeters ang iyang sa ni diameter sa iyang thread. Gamay kaya, no? So it is defined as the moisture content in percent. So of course you are aware already of its moisture content based on laboratory analysis, at which the soil crumbles and rolled into threads at 3 millimeters. Okay, if it is wet, it breaks at smaller diameter. So kung basa ang imong sample, smaller pa aning 3 millimeter diameter ang usa siya maputol. If it is dry, then the possibilities are or is it will break at a diameter larger than 3 millimeters. So kung dry man good, mean to say, lisod kayo ang bonding sa imuhang, ay molecular bonding sa imuhang clay minerals inside your sample. That's why it will eventually or it will break because the plasticity of your clay is not increased in this case. But because if water is added, then the plasticity of your clay will be increased kasi your molecular bonds are being or it is becoming stronger because of the water molecules that bonds with your clay minerals. That's why usa siya ma-break kung magkakaroon or lesser than 3 millimeters na equal or less than 3 millimeters na diameter sa imong thread imong thread sa imong sample. I-roll yun nimo mura siya lundrison. Mura ka garolyo og imong dalikdik. Nakakuan ba mo ana? Nakasulay ba mo ana? Magrolyo mo sa inyong dalikdik. Pila ka millimeters ang inyong dalikdik o sa maputol. Yaks. Have you tried or alam niyo yung dalikdik guys? Libag guys, libag.
Yes, sir.
Yes, sir.
Tamo nagkabalo ko nang likit na mo sa inyong dalikdik. So, 'di ba nganong i-roll nimo siya. Pag wala kay ligo-ligo pila ka adlaw, imo siyang i-rub, maka-feel ka nga, oy, akong mga dead skin cells nag-occur. So, magsige kag rolyo ana guys, mutaas man na, 'di ba? Yung ana ng plastic limit sa imuhang skin itself or dead skin cells itself. Yes.
So ano ginagamit nila pang roll? Parang pizza roller, i-roll lang na parang pizza dough, ganyan.
Ay hindi. Mura siya og i-thread ba? I-thread like gamay lang na sample tayo. Hindi mo kailangang malaking sample. I-roll lang siya. Mura kag gagamit ng rolling pin parang pizza dough pero dili pud nang mura og mugama ka og pita bread or pizza dough. Okay? Hindi ganun. Thread lang, murag thread ba? Murag laundrison. Alam mo yung laundress sinulid ba? Ganun yung
Hindi
itsura.
gets, sir.
Okay. Right. Question pa. If wala, check ko muna attendance niya. So next meeting, ang atong lecture will be shear strength of your soil. So again, mathematical symbols na naman, marami na namang equations, and bear with this topic kasi mo guni ang engineering geology, guys. Welcome to our field. Ano ng engineering geology? Wow, dami. Kakamatay, yung dami. Moment. Section B. Today is 6/17. Ay, di putik. Abing, Jessa,
Present, sir.
Alivio, Henton,
Present, sir.
Asingwa, Rachel,
Present, sir.
Kalibat,
Present, sir.
Trisha, Del Prado, Thea,
Present, sir.
Gases,
Present, sir.
Ira,
Present, sir.
Kingkong, Aldrin,
Present, sir.
Magbanwa, Cyrac, absent si Magbanwa, Manyara, Sofia,
Present, sir.
Munaske, Jude Ivan,
Present, sir.
Ohario, Aloha,
Present, sir.
Palomar, Kingsley,
Present, sir.
Pialago, Joseph,
Present, sir.
Remitor, Nika Angela,
Present, sir.
Rustian, Nathan James Francis,
Present, sir.
Theodore Sanchez,
Present.
Sarita, Daniel,
Present, sir.
Sumargo, Marinel,
Present, sir.
Inido, Ralph,
Present, sir.
Miguel, Karen,
Present, sir. Present, sir.
Villegas, Felipe.
Present, sir.
Kinsa tong ni kon kanina ni recite si Sarita to no, si Sarita. Kinsa pa to si Theo. Kinsa pa to?
Ako po, sir.
Wait.
Sir.
Kinsa to?
Manyara.
Dito, sir.
Tenido and Manyara. Tenido and Manyara. Alright. So, okay na. Sige. I guess if you do not have any more concerns, you can now leave the meeting.
Thank you, sir.
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 Sir. Thank you, sir.
Thank you, sir.